Dear students, let us continue our learning the core system software and compilers. This is the 11th session of the module 3. The topics covered under this session are from the chapter syntax analysis under the title bottom up parsing, under that one ShiftReduce parsing and the conflicts during the ShiftReduce parsing. Myself, Dr. Suresha.d from the Department of Computer Science and Engineering of Canara Engineering College, Mangaluru, Mangaluru. In the last video, we identify how to identify the handle and how to apply the reduction steps over there. Let us continue with it and let us start with the next topic, that is our shift reduce parsing. So the bottom up parsers use the shift reduce parsing in the parsing the input. How this shift reduce parsing will work? Right? So if you observe the top down parsing, so in the top down parsing, what happens is first initially we used to have a stack. We used to have the stack and the input. So stack and the input, and the stack we used to push our start symbol over there. So let us take the example of our E. So E is our start symbol. E and the dollar we used to push it to the stack, and the input will be the W and the dollar we used to put. At the end, to be get accepted, we need to have the stack should be empty and the input should be empty. Stack should be empty and the input should be empty to say that the given input is accepted. So under the top down parsing. So under the top down parsing, this is how we used to do. So this is what we have explained in the last video. So now let us go with the bottom up parsing. In the bottom up parsing, what we will do is, so we will keep the stack empty. We'll keep the stack empty and we will have the input as W. So we'll keep the stack empty, right? So how the top down parsing works? So we start from your root symbol. In the top down parsing, we start from the root symbol and we keep on continuing till I get the leaves. The leaves will be my W. The leaves will be my W. So as you remember, in the bottom of parsing, I need to start from the W and I need to work upwards. And I need to work upwards till I get the root over there. So this was my bottom of parsing. Right? So that is, I will start from this W. So W is my input. I will start from this W and I will work upwards. So that is one step at a time. I will work upwards one step at a time until I get my root. That is my start symbol. I need to get over here. Okay? So till that time I need to work out. So if I am able to get my start symbol, then I will say that the given input is accepted, or else it will be get rejected, or else it will be get rejected. Right? The same mechanism I am applying over here. That is, shift reduce parsing is a form of bottom up parsing, in which the stack holds the grammar symbol and an input buffer holds the rest of the string to be parsed. Right? So then next we use the dollar to mark the bottom of the stack and the right end of the input. So then next we stack on the right. Okay? So now we work on the upwards and we will try to get the string W. The scanning happen from left to right. The scanning happen from left to right, and it will shift 0 or the more input symbol on the stack until it is ready to reduce a string, a bit of the grammar of the symbol on the top of the stack. Right? So how it will work, let us see. So when we go with the shift reduce parsing, mainly there are 4 different actions are there. There are 4 different actions are there. The first one is the shift, which is nothing but pushing the element to the stack. Inserting the element to the stack, we call it as a shift. Inserting the element to the stack, we call it as a shift over there. Reduce, when the stack contents matches with the body of the production. So let us take the example of our E derives E plus T. E derives E plus T. So now when the stack as E plus T, now this E plus T will be taken out and in place of this E, I will push this E. I hope it is clear, fine. So that is when the stack has E plus T, when the stack has E plus T, I will take out this E plus T. That is, I will pop this E plus T, and in place of that one, I am going to push this E. So that step we call it as a reduce. So now this will be our handle. This will be our handle, fine. So whenever there will be an handle which is identified on the top of the stack, what we will do is we will take out that handle and we will push the root of the production. We will push the root of the production, that is the left side of the production, onto the top of the stack. That step we call it as the reduce over there. Then if I am able to successfully complete my parsing, then I will announce that it is an error. It is accepted. If I am able to successfully complete the parsing, then I will say that the given input is accepted over there. That is a successful completion. If there is any error, any error over there, then I will announce that it is an error. Fine. So now let us see the example which is given in the textbook, and we will take the other example. So now let us look how it will work. Right. So initially we start with the empty stack dollar, and the input is ID star ID dollar. So we will push ID to the stack. So now what is our grammar productions? E derives E plus T, E derives E plus T or the T, E derives E plus T or the T. Then next is T derives T star F, T derives T star F or the F. Then F derives open parenthesis expression and the close parenthesis are the ID. So now this is what our grammar is. Fine. So now I will push the ID to the stack. Now I will look at the top of the stack. What is the top of the stack? ID. So now it is a handle. So now whenever we get the handle, we remove the body of the production and we will push the left side of the production. So now ID is identified, the left side of the production is F. So now ID is removed. In place of this ID, F will be pushed to the stack. Again, F is handle. So now F will be taken out and T will be pushed to the stack. So now even though the T is a handle for the E, but we won't go for reduce because the next symbol is a star. So we will retain that T as it is. Then I will push the star to the stack. Then next will be the ID. ID will be pushed to the stack. Again, ID is a handle. So now ID is replaced with the F. So now what I have the T star F. F is also a handle and T star F is also a handle. But we always go the longest match. So T star F is a handle that will be replaced with the T. Then next T is a handle that is replaced with the E. Fine. So that is it. Initially we started with our input ID star ID and we are able to get our start symbol. Then we say that the given input is accepted. Accepted, or else the given input is rejected over there. Or the given input is rejected. Now let us take one more example. We start with the stack. Input and the action. For the action we are applying. So initially we start with the empty stack. Let the empty stack be dollar, and let the input be, let us take the input as ID star bracket ID plus ID close. So now I will end with the dollar. So first action is I will shift this ID to the stack. The first action is shift. Earlier it was just empty stack. Now I will shift the ID. The action is a shift. The action is a shift. Now ID is a handle. So now ID is a handle. So now this ID is replaced with the F. Now this ID is replaced with the F. Okay. So next F is a handle again. So I will replace with the its left side of the production, that is T. Again T is a handle, but I am not replacing with the E over there because the next symbol is a star. Since the next symbol is a star, I am not replacing over there. Fine. So now here the left out is a star ID plus ID and the dollar. So till here what I applied is the reduction step. Till here I applied the reduction steps. So next I will shift the star. The next action is a shift. I will shift the star over there. That is a T and the star. Again the next action is again the shift. That is a open parenthesis is shifted. Next action is again the shift. That is ID is shifted. ID is shifted. Now the ID is a handle. Now ID is a handle. ID is replaced with the F. Again F is a handle. F is replaced with the T. Again T is a handle. T is replaced with the E. T is replaced with the E. Here we are not replacing, but here we are replacing because the next symbol is plus. The next symbol is a plus. So for the plus to have the matching, we should have the E over here. We should have the E over here. So we are replacing. So now what is our stack content? It is a $T star open parenthesis and the E. So now again till here the action is reduced. Till here the action is reduced. So again the next one, what is left out here? The left out here is so star open parenthesis ID we have shifted. The left out is a plus ID over here. Plus ID closing and the dollar. Again plus is shifted here. Again ID is shifted. Then the next action is shifting the plus, then shifting the ID. Again there is a match. Again there is a match over here. So now what I have? I have a $T star open parenthesis E plus and the ID. So now ID is a handle. So ID is a reduction step is a ID is to be replaced with the F. Then again F is a handle. F is to be replaced with the T. F is to be replaced with the T. The action is reduced. The action is reduced. So now what I have $T star open parenthesis E plus T. So now E plus T is a handle. So E plus T is a handle for the E. Fine. So now E plus T is replaced with the E over this. Whenever we get the handle, we will replace. E plus T is replaced with the E. That is the T star. E plus T is replaced with the E over there. So now the next left out. What is the left out over there? Closing and the dollar. So now closing is shifted. Now next action is the shift. Closing is shifted. So now again it is a handle. Handle of what? F derives so open E and the close. So now I have. So this will be replaced with the $T and open E and the close, that will be replaced with the F. Again T star F is a handle. This will be replaced with the T. So again T is a handle, that will be replaced with the E over there. So now here nothing left out. So because here it is shifted over here. Right? So now we started with the input and we are able to get our start symbol. So we are able to get our start symbol. Then we say that it is accepted. Then we say that given string is accepted. Let us take the example where it is going to reject the given string. Fine. Where it is going to reject the given string. Fine. So now let us take the example of let us take the example over here. ID plus ID input R. So first I will shift this ID. So it will be ID. So now ID is a handle. I will replace this ID with the F. F is a handle. I will replace this F with the T. T is a handle. I will replace with the E. Because the next symbol is a plus, so I am replacing the T with the E. So now what is left out on the here? So I have left out is a E. So left out is a plus plus ID. Plus ID. So again plus is shifted. E plus. Again the next plus is shifted. E plus plus. Again the next ID is shifted. Now ID is a handle. I will replace with the T. F. F is a handle. I will replace with the T. So now what I have E plus plus T. E plus plus T. So nowhere it is matching. So our matching is E derived E plus T, not plus plus T. So nowhere it is matching. Now in the stack I have E plus plus T, and here the input is empty. Here the input is empty. Nowhere I can shift over there. Nowhere I can reduce over here. Then I will say that it's an error. Then I will say that it is a parsing error, that is a syntax error. That's what the syntax error is. Right? So at the end, I should get only the start symbol over here, but I am getting E plus plus T over there, which I am not able to reduce. Then we say that the given input is rejected. This is how the shift reduce parsing works. So the four operations in the shift reduce parsing are: first one is a shift. Shift is inserting the element to the stack. We call it as a shifting. Reducing, whenever we find any handle, that is the body of the production, that is replaced with the, that is taken out from the stack. That is, it is popped from the stack and it is replaced with the head of the production or the left side of the production. That will be your reduce action. Then at the end, if I am able to get the only the start symbol in the stack and input is empty, then we say that it is accepted. If it won't happen, then we say that it is rejected. It's an error, and we will call the error recovery routine. And this will happen one step at a time. Fine. So now you can see over here that is S derives E alpha A Z, and this A derives alpha B Y. Fine. Then B derives gamma over there. Fine. So this is my rightmost derivation. So this is the ultimate thing. So now what happens? First I will reshift this alpha, then next gamma, then next x. So once I get this x, fine. So once I get this gamma is replaced with the my head of the production is a beta over here. So that is a beta over here. So that is a beta b. So that is a let us take the example of alpha b x a z. Right? So next b derives as it is, capital A derives y. Right? So then next b derives gamma over here. So now once I get this gamma, so gamma is replaced with the b. Next I will shift the x. Then next once I get this y, this y is replaced with the a. The next z is shifted. So now once I get alpha b x a z, so this is replaced with the yes. So this whole thing is replaced with the yes. That is, we apply the reverse of the rightmost derivation. Shift reduce parsing is nothing but the reverse of the rightmost derivation. What we've explained in the last class while identifying the handle. It is the reverse of the rightmost derivation over. And each reduction or the insertion happen one at a time. It will happen one at a time. These are the two cases over here. So wherein two successive steps are shown. So in this case, we are having a derivation only in the middle over here. Here along the two sides, we are having the reduction. So gamma is replaced with the A, B, Y is replaced with the A. Then it is alpha, B, X, A, Z is replaced with the X. Right? These are the two successive steps in the rightmost derivation. So next one. The next topic is the conflicts which happen during the shift reduce parsing. Right? So now let us take our old example. So if my input is, I will start with the ED. If my input is ID, so this is stack ID star ID dollar. So first what I will do, I will shift this ID. Then this ID I will reduce with the F. This F I will reduce with the T. This F I reduce with the T. So now if I take the production E derives, the production is E derives E plus T or the T, right? E derives E plus T or the T. And it is T derives T star F or the F. T star F or the F. And F derives open parenthesis expression close parenthesis or the ID. So now for the ID we replace with the F. For the F I replace with the T. Again for the T I should replace with the E. That is, what is that action over there? That is, I need to apply the reduction over there. I need to apply the reduction. I need to apply the reduction. But if I reduce this one to E, I can't have the star over there. The next one is star. Star is over here. T star F. That is, I need to retain this T and I need to shift this star. I need to shift this star by retaining the T. Actually, I need to reduce. But what I have done, I have done the action as a shift. Even though I need to go for reduce, but depending on the next input symbol, I went with the operation also for shift. This conflict we call it as a shift reduce conflict. This conflict we call it as a shift reduce conflict. It is in first type of conflict during the shift reduce parsing. That is either to shift or to reduce. Which one should I apply? Whether I should have, here in this case the favor goes in terms of the shift. The favor goes in terms of the shift because the next input symbol is a star, and if I go for reduce that T to E, I can't able to parse my star. So that's why the favor will be, the priority will be given for the shift action. Fine, but it's in conflict. Fine, so it's in conflict. That conflict we call it as a shift reduce conflict. It is the first type of conflict. Then the second type of conflict. The second type of conflict, let me have in production called E derives A, and I have T derives A. E derives A and the T derives A. And if my input is A, and the dollar. So now first I will shift this A. So A I will shift. Now this A I need to reduce. So now reduce it with what? So now it is matching over here. So if I take up this one, it is one type of reduce action. That is, I need to reduce with E. If I take up the first production. If I take up the second production, I need to reduce with the T. Because in both the places it is matching. Here also it is matching, here also it is matching, here also it is matching. That is, now I have the conflict of reduce with E or the reduce with T. Such a conflict we call it as a reduce conflict. Such an conflict we call it as the reduce conflict. These are the two different types of conflicts which may appear during the shift reduce parsing. That is a shift reduce conflict or the reduce conflict. So shift reduce conflict example is this one. So example is this one, and the reduce conflict example is this one. Right? So, now fine. One is the shift reduce conflict, other is the reduce conflict. So now in this example, they have taken the example of if expression over here. So first I shift this one, if expression then statement. Then I have the else over here. Then I have the else over here. So whether I should reduce this, one to statement, because it's matching over here, if expression then statement, whether I should reduce this one or I need to shift this one. Look here. I need to shift this one. This is a conflict. This is a conflict. Fine. So whatever is available in the stack, it is matching with the body of the production, one of the body of the production. The content in the stack is matching with the one of the body of the production. So, so the required action is I need to reduce. But if I look at the rest of the input, I need to shift, because if I am not able to shift, if I go for reducing it, then it is a statement, else statement, which is not which I am not able to reduce, Right? So such a conflict we call it as the shift reduce conflict. Such conflict we call it as the shift reduce conflict. Then the other example for the reduce conflict. Other example for the reduce conflict. Let us go with the your function parameter parsing. So statement derives identifier and the parameter list. Statement can be an expression equal to expression. It's an assignment statement. Parameter list can be a parameter list, comma parameter, or it can be a single parameter. So parameter can be an identifier over there. So example will be your sum of a comma b. So sum of a comma b. Fine. So this is an example for your function call. This is an example for the function call. Fine. That parameter can be an identifier over there. So now let us go with this expression. Expression can be an identifier followed by the expression list. Identifier can be followed by the expression list, and the expression can be an identifier, or expression can be an identifier. So now when I get this identifier, where and all it is matching, here also it is matching, here also it is matching. So now whenever I will get this ID, fine. So now what to do? So whether I should reduce with the expression or I should reduce with the parameter, which one should I take? Such a conflict will be your reduce conflict. Such an example will be your example for the reduce conflict. Okay? So these examples are the examples for the reduce conflict. Okay? So now this completes this chapter. So in this chapter we started with the bottom up parsing. In the bottom up parsing, we have started with the what is reduction over there. Then next we went with the identifying the handle which is needed for the reduction. Fine. The identifying the handle is very important. Once that identifying the handle is done, for identifying the handle, so we go for the applying the rightmost derivation in reverse. Applying the rightmost derivation in the reverse over there. So this is how we can identify the handle. Fine. So once that handle identification is done, then next will be your shift reduce parsing. So in the shift reduce, there are 4 actions are there: shift, reduce, accept, and the error. Fine. Shifting is inserting the element to the stack. Reducing is whenever we get the body of the production that is replaced with the head of the production. The next at the end, if I get only the start symbol in the stack and the input is empty, then we say that it is accepted. If not, then we say that it is an error and we call the error recovery routine. So after that one, we studied the conflicts in the shift reduce parsing. The conflicts are shift reduce conflict and the reduce conflict. Right? This completes this module. This completes the module 3. Next, we'll look forward in the next module. So the reference for this presentation are taken from the textbook Alfred V. Ho, Monica S. Lem, Ravi Sethi, Jeffrey D. Ullman. These are the authors. The textbook is Compilers, Principles, Techniques and the Tools. Pearson publication, second edition, 2007. Thank you.